Well, I'm starting to have a bit of interest in, or a few viewers I should say, I guess some interest in this tuner that I built, geez, about a year or so ago I suppose. I actually haven't done a thing with this since I built it. The only thing I really wanted to change for anything, for the most part, I want to change out the wire and run coax up to this instead. But in any event, this is what I managed to figure out with the ins and outputs and stuff. So basically what you get an input and ground, which is your output on this capacitor. You get it in and out. That's pretty much all I could find with this one. It's also got a roller inductor as well. Runs quite smoothly. Yeah, the coils needs to be cleaned up, that's for sure. And I believe you mentioned deoxit. I could probably try that, I suppose. I was even toying with the idea of doing electrolysis on this, clean it up that way. Electrolysis will get into every little nick and cranny. Clean up the whole thing with electrolysis, and then oil it up, the bearings and stuff in here. Yeah, a bit of dust and stuff in there, so really needs to be cleaned up. But I mean, I don't really want to disassemble this thing because already that's even God put her back together. The only thing is, everybody knows she had a crack going down here. This is actually ceramic, so if I was to try to fix this, I need some kind of ceramic adhesive to fix this piece. And even then, with disassembling the whole unit just to fix this, it's just as well just leave it alone. But I don't know, I know what you mean. I should fix it in that, but you know, it's quite stable. I can try to rotate this, and you know, there's no giving it whatsoever. Now this is mounted on something, it's pretty firm. This should be fine. But yeah, maybe later on down the road I'll do something with that crack. But yeah, I know what you mean. Should fix it. But so I'm going to take the cover off of this, and we'll have a peek on the inside again and see how I got this thing wired up. But as you can see, we have an input and we have an output, which is ground. But it's, yeah. But anyway, like you're saying, on your coil you had there's three parts to it. Obviously you had your coil, your length of your coil, two contacts for your coil length, and then you had the other piece for the other connection for up here. And for that to be up here on this one, your roller, or I should say the roller, is on this contact here, and the coil connects from here, connects here, and if I'm not mistaken, the other end of it should be over here, which it is, and you can see I see what you mean. There should be a connection over here, and there's not. So I'm not actually utilizing the full length of the coil as such. The coil should be grounded on one end, and it's not. Okay. Well, maybe what I should do is get myself a piece of copper braid and connect between Exhibit A and Exhibit B. Ground the coil on this end. Yeah, that would probably make more sense, hey boys. Because right now I'm not actually utilizing the whole coil. I am, and I'm not. Basically all this is making the coil longer or shorter than as much as all this one is doing. And we're tapping off as you roll them down or up and down. Alright, let's take the cover off this thing and see how I got her wired up. Okay, this is the inside of the coil. Just remember the black wire is ground on the coil, and the white wire here is what connects to the roller on the coil. So you have your antenna in to one cap, and you have antenna out on the other cap. You have a connection between both of them, which goes out to the white, goes to the coil back here. And of course ground is going straight to ground. So yeah, and the case I built this in is, because you asked a question about the case, and the case is from an old switch and power supply, an old SCC 12, SSC 1212 or 12012, whatever, 1212, 12 volt switch and transformer or power supply. The power supply kicked a bucket, and I managed to keep the case. And I can get my hands on a nice few of these little cases for projects whenever I want them, pretty much. But yeah, so that's the inputs and outputs, these two wires, and the white one goes back to the roller on the inductor, and the black is your ground. That's how she's wired up. But I guess more than anything, I guess we can try some continuity here and see how this thing is wired up. Okay guys, I'm meters on continuity, which we're getting reference to ground here. So with reference to the capacitors, input goes to the stators, and as you can see, there's no connection to ground either on the input or on the output. Now the coil, on the other hand, gets this ground through the capacitors. So you got the RF comes in through your caps, goes back to the inductor, and your inductor is doing your grounding, your inductance through the grounding out to your output. Yeah, and of course there goes the lead. Put the ground back there. So again, your coil goes to ground, as you can see. I see a problem. Do you guys see a problem? Because I see a problem. I see a very big problem. I have my coil supposedly grounded over here. You see a problem? I forgot that myself. So the only ground this coil is getting is when I got the side screws put in. Well, I need to run a wire to properly ground this cover to this one. So, looks like I'm going to have to run a wire, a ground wire from here to there. So we got this case here properly grounded. I'm going to put the cover back on this, put a couple screws in it, and see if this stays grounded. I never noticed this, folks. I really didn't. I did not notice that this wasn't grounded. Alright, let's see how well the ground is when the screws are in. And I bet you this has very little ground. Alright, so I got two screws put in on this side here. So let's see how well the grounding is here. Okay, so the case cabinet, the cover is getting its ground through screws. I really should have a wire to do a proper bond between these two plates. should do that. Alright folks, so I'm going to see how good the continuity is between this roller and the coil going all the way across itself. Right now I have the roller off of the coil here, as you can tell. So let's roll her along here, and you listen for the buzzing in the meter there. And she sounds scratchy. That's where she's got some poor connections going across the length of the coil. So let's have a listen. I try not to annoy you too much, but dead spot there, see that? If you're really slow, you'll notice it more. Hear the scratchiness in the meter. The coil definitely needs to be cleaned. There's no doubt about that. The coil on that roller, along with the rod that the roller goes across on. Fairly dirty all the way along. There you have it. Yes, my coil and rollers needs a good cleaning. There's no doubt of that. So I guess that's the next thing. I'm going to clean this the next series of videos, I suppose. We'll see if we can clean this coil. I'm not sure how hard it would be to do it with electrolysis. I don't know if it'll fit down into my glass jar I use it for electrolysis or not. It might. Anyway, so there we have it. That is my tuner that needs a little bit of work, and it is from, oh, there you go, SCC 1223. SCC 1223. So that's what this case is, from an old power supply. Anyway guys, hope you enjoyed the video, and we shall see what transpires with this thing. And the inductor, according to what's wrote on here, don't know if it's right or not, but it looks like it's 24 microhenries, or millihenries, whatever you want to call it. So there we have it. Anyway folks, hope you enjoyed the video, and got any ideas how to clean it, let me know. And so far it looks like deoxit is the popular solution. Anyways, all the best. Thanks for watching.